Okay, I'm going over unit 12, 13, and 32, which is pages 121 through 126, 131 through 136, and 321 through 326. So starting on page 121. Oops. So it says, which of the following is not true about the linear graph of, or about the graph of a linear relationship? So we need to tap back into our notes. A linear relationship involves a straight line. We can use the equations y equals mx plus b. Sometimes the b is a 0. It can go through origin. Okay, it can pass through the origin or not. That depends on if b is equal to 0, it's proportional. If b does not equal 0, then it's not proportional. Both of them are still linear relationships. And m is the slope, which means it's a constant rate of change. Constant ROC. Okay, so all of these have to do with linear relationships, and it's asking about which one does not. Okay, number 2. Look at the graphs. Which of the following is true for both graphs? Well, let's observe. This appears to be increasing. If I were to draw a line of best fit, increasing, and it's linear. This appears to be decreasing, and it's still linear. So decreasing, linear. So it says as the number of missed classes goes up, our test scores go down. And as the number of hours spent studying goes up, our test scores go up. So it says both graphs suggest nonlinear relationships because neither one contains a line. Both graphs suggest linear relationship because there appears to be a constant rate of change. Both graphs suggest nonlinear relationships, or there's not enough information given to draw conclusions about the graphs. I think I gave you enough for you to choose the proper answer. Number 3, this is a curve. Remember, linear must be in a straight line or form a straight line pattern. And I need 2 answers about this data. So this is nonlinear. It tends to go up, then it tends to go down. And a linear relationship will consistently go up or consistently go down. It will not do both. So the 2 answers that you need to choose from are A through E. This says the graph suggests a nonlinear relationship between X and Y because there's not a constant slope. And we want the one that's not true. So I'm looking for 2 answers that are false. Page 122, number 1. This appears to be going at a increasing linear rate. Increasing, linear, constant rate of change. And it could be formed with y equals mx plus b. All right, number 2. It says look at the graphs. This is going down first, then increasing. This is nonlinear because it's not a consistent rate of change or not a constant rate of change because my rate of change goes down first, then it changes and goes up, and that's not what I need. And then this is steadily going down. It is linear because I can draw a straight line through it and my points will follow the pattern. Good morning, I'm going over our homework. I'm about to turn to page 125. All right, number 4. I can draw a line through this data, which means there is a linear pattern. It constantly increases This, I cannot form a straight line. This is just a glob of points here. They do not follow the line as I draw it upward or downward. Please don't talk. Don't come in here talking. I'm recording. Okay. There's no consistent increase or decrease. Down here at number 5, let me zoom out a bit. It says a study was conducted to determine what type of relationship, if any, exists between the number of children in a household and the travel time between school and home. The data is shown in the graph. Is there a relationship between the number of children in a household and the travel time between school and home? Well, let's draw a straight line. My points are not following my line upward. It's another blob. This is non-linear, no constant increase or decrease. All right, on to page, by y'all, 131, because I'm keeping it moving. This says Carter owns an ice cream cart and sells various flavors of ice cream cones. We did this one in class. Okay, but just to go over it again, I think this is making predictions where we're drawing a line of best fit and it's increasing steadily. Close my door, please. So if I draw a line of best fit or if I use my patty paper, I can make a prediction here. And then I'm going through to answer these statements to see if they are true. When the temperature is 55 degrees, Carter sells about 55 ice cream cones. So I'm going to go to about 55. And that's going to be about right here. Make my point big because it's an estimate. And then if I come about right here, I need something about halfway between 50 and 100, which would be 75. And this right here would be 125. This is 175. This is 225. This is 275. And I would also need to extend it because I'm making predictions. So my 350 would be about here, and my 375 would be about here. So I need to read through each of these to see which one makes sense. Also, we can't sell a negative number of ice cream cones, so that should rule out that answer completely. Then it says number 2, based on the trend line, which is the best prediction of the number of cones sold when the temperature hits 100 degrees Fahrenheit. So again, with my line of best fit, I need to come here and estimate about where 100 would be. So I would come all the way up here, boom, see where it meets, and then come all the way over here, boom, see where it meets. So it would put me about right here. Number 3, it says scientists tracked the traveling distance of a blue whale named Beauregard over several days. Based on their findings, the scientists predict that after 80 days, the blue whale will be 2,400 meters away. Which set of data produces a trend line that models this prediction? So I need 2,400 meters in 80 days. So my number of days is my x-axis. My meters are my y-axis. And if I look at every single one of these y-axes, they stop at 1,000. 2,400 is double that and then 400 more. So I need to be like way up here from this one, way up here for this one, and way up here for this one. So I need to extend my axes, extend that one, extend, and extend, and I also need to extend to 80, and extend, and extend. Okay? So I need to find out where 80 days will match 2,400 about. So let's start with the first one. Here's my patty paper and my trend line. If I'm going this way, at about 80 days would stop right about here. So let me mark that on my paper. Right about here. My 2400 is way up here, so this is not going to work. No go. So then over here, I'm going to come and try and meet my 80, which would be about up here. I have passed my line here, so this won't work either because of this gap here. This is a nope. Down here, the 80 would be about, whoa, need to erase some of my marks, would be right here. The line isn't even coming through here, so this is also a no. I think I've eliminated all the wrong answers for you. You're welcome. Don't come in here talking. Don't come in here talking. I am recording. I shouldn't have to repeat myself. Not right now. The scatter plot shows the percent body fat for people who regularly exercise each day. So if I look at my trend line, I'm going to have to show you during class. My data is going downward in a linear pattern, and I have about the same number of points on the bottom as I do on the top. And let's see what it tells me. If the scatter plot displayed more data, which possible points could be included in the graph? I need 2 possible points. So let's look about here. It's getting 2.5, 3, 4, 4.5, 5. So I need to extend my x-axis. This is 3. This is about 4. And yes, I'm writing on to my next question. And I'm going to have to see what I can do here. Maybe I should trace my line on my paper. That might be a good idea. Let's trace a little bit. All right, so the 3 comes right about here. The 2 is right about here at 18. The 4 is about here at 10. And these are just estimates. It's not going to be exact. So my data is going down. Oh, you know what? This isn't a best fit line because it doesn't go exactly halfway through both points. So let's retrace my line. Let me make a more accurate line. I've got some points on the bottom, some on the top. There we go. So now my 3 has moved up a bit and I'm halfway through my data. Some points on the bottom, some points on the top. My 4 is here. So let's see. 4 is still about less than 10. 3 is about 14. So 2.5 should be at 12. 2.5 is up here at 22-ish. So that's going to be too small of a y coordinate. 320. This is about 14, but I do know that it needs to be less than 22. So maybe 3 and 20 will work. 4 and 25 is impossible because my y coordinate is too large of a y coordinate. Y coordinate. 4.5 and 20 is still too big because 3 is around 14 and 18. Too large of a y coordinate. And 5 and 12, well, 4 is about over here. So I guess this would be another good estimate. So none of these are exactly correct. They are going to be estimates because, again, my line of best fit is not exactly the line that's going to go through these points. We have to estimate where this data is going, which is downward. Number 2, based on the trend line, which is the best estimate of the number of hours of exercise per day needed to reach a body fat percentage of 16? So I need to come over here to my 16, which is right about here. So somewhere between 3 and 4 I would say, since I said that 5 and 12 works,